With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I hope you all are doing good. So today our question is like this. We have for a reaction 4NH3 gaseous plus 5O2 gaseous equilibrium 4NO gaseous plus 6H2O gaseous, and we have to write the expression of equilibrium constant Kc for this reaction. So this is a very basic question from the equilibrium constant. So let us take a general reaction like this: AA plus BB equilibrium CC plus DD. So I am taking a general reaction and I will write the expression for Kc for this reaction. So expression for equilibrium constant Kc will be equals to, for this reaction will be equals to, concentration of products to the power stoichiometric coefficient of products divided by concentration of reactants to the power stoichiometric coefficient of reactants. We have to take separate products concentration in the numerator and we have to take separate reactants concentration in the denominator, and we have to take stoichiometric coefficient according to the product. Okay, so it will be concentration of product to the power stoichiometric coefficient divided by concentration of reactants to the power stoichiometric coefficient. And in this general reaction we have two products like C and D, so we will take the concentration of C, that is capital C and capital D. Okay, we have product like capital C and capital D, and we have small c and small d are stoichiometric coefficient of capital C and capital D respectively. So Kc will be equals to concentration of capital C to the power small c, because small c is the stoichiometric coefficient of capital C. Okay, so Kc will be equals to concentration of capital C to the power small c, because small c is the stoichiometric coefficient of capital C, into concentration of capital D to the power small d, here small d is the stoichiometric coefficient of capital D, divided by concentration of capital A to the power small a into concentration of capital B to the power small b. Here capital A to the power small a, here small a is the stoichiometric coefficient of capital A is the reactant, capital A is the reactant, into concentration of capital B, here capital B is also a reactant. Okay, so it will be concentration of capital B to the power stoichiometric coefficient of capital B, that is small b. So this is a general Kc expression for this general reaction. A plus B gives Cc plus Dd. So Kc will be equals to C to the power C into D to the power D divided by A to the power A into B to the power B. It will be easier for you to learn this type of expression because it is quite easier to learn, because Kc is equals to concentration of C to the power C into concentration of D to the power D, concentration of A to the power A into concentration of B to the power B. Okay, here small a, small b, small c, small d are stoichiometric coefficient of capital A, capital B, capital C and capital D respectively. Okay, so you need to just learn this formula, that is Kc equals to concentration of products to the power stoichiometric coefficient of products divided by concentration of reactants to the power stoichiometric coefficient of reactants. Okay, here we have to take separate products. If we have three products, then we have to take the concentration of three products separately. Okay, so this is the basic expression for this general reaction. Okay, now we have a reaction like this. We have 4NH3 gaseous plus 5O2 gaseous equilibrium 4NO gaseous plus 6H2O gaseous. Now we have to write the expression for equilibrium constant Kc for this. So Kc will be equals to concentration of products to the power stoichiometric coefficient divided by concentration of reactants to the power stoichiometric coefficient. Okay, so we have products like NO and H2O, so it will be Kc will be equals to concentration of NO to the power stoichiometric coefficient of NO. What is the stoichiometric coefficient of NO? It is 4, into concentration of H2O to the power stoichiometric coefficient of H2O. And what is the stoichiometric coefficient of H2O? That is 6, divided by concentration of reactants to the power stoichiometric coefficient. And what are reactants in this? We have NH3 and O2 as reactants, so it will be concentration of NH3 to the power stoichiometric coefficient of NH3. What is stoichiometric coefficient of NH3? 4, into concentration of O2 to the power stoichiometric coefficient of O2. What is the stoichiometric coefficient of O2? That is 5. So this is the general expression for Kc for the above reaction, that is 4NH3 plus 5O2 gives 4NO plus 6H2O. So this is the expression for Kc for the above reaction. Okay guys, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.